If you have a boiler or a furnace, you can clock a gas meter to see how many BTUs that appliance is actually using. It's the same formula either way. It's just what you got to figure out is, one thing you need to know is, are you using natural gas or are you using liquid propane? So natural gas is figured at 1,000 BTUs an hour per cubic foot of gas, and liquid propane is 2516 BTUs an hour. I like this formula the best because it allows you to kind of figure in an average. I'll show you that in a minute. So what you do is you pick how many dial revolutions you want to do. So let's say you want to do 3 revolutions, and you start a stopwatch on your phone or a stopwatch, and you count in seconds how many times does it take to do those 3 revolutions. So you take the dial revolutions divided by the seconds to do those revolutions. You take it times your dial size. So on a gas meter, you're going to have different dial sizes. On a smaller one, you might have a 1 cubic foot dial. You could have a 5 cubic foot dial. And then you take that times 3,600 seconds an hour, because that's how many seconds are in an hour, times your gas rating BTUs per cubic foot. So if it's natural gas, you take that times 1,000. If it is LP, you take it times 2516. So for an example, say it took 60 seconds to do 4 revolutions, and we were using the 5 cubic foot dial. 3,600 is always 3,600, and then we're going to use natural gas. So we plug all that stuff into the equation. So 4 revolutions divided by 60 seconds times the 5 cubic foot dial times 3,600 seconds per hour times 1,000 BTUs per cubic foot of natural gas. So that ends up being, the 4 divided by 60 ends up being this long decimal, 0.066, times 5 cubic foot dial times 3,600 seconds per hour times 1,000. So you end up at 1.2 million BTUs an hour. So this is clearly a boiler or a big makeup air unit or something like that. Obviously, it's not a furnace at home that's 70 or 80,000 BTUs. The other thing you got to keep in mind is when you're clocking that gas meter, you need to make sure that there's not other gas appliances using the gas, because you're trying to figure out what this specific appliance is using. Another way you can do it is you figure out the cubic feet per hour, and then you take, so the cubic feet an hour is 3,600 seconds times the dial size divided by the time in seconds for 1 revolution. The problem here is that you're only counting 1 revolution, so you could take the 3,600 times 5 cubic foot divided by what it took in 1 revolution, and then that ends up being your CFH, so cubic feet an hour. Well, then you got to figure out your BTUs an hour, which is cubic feet an hour times gas rating BTUs per cubic foot. So if it's natural gas, you'd take that times 1,000, and then that's how many BTUs you were burning in that 1 revolution of the dial. Now you could do that 3 times. You could add it together, divide by 3 to get a better average. It's just this way up here, it's a lot easier in my opinion. It may look a little bit more intimidating, but you're going to get a better result because you're kind of building in the average based on how many revolutions. You could do 3 revolutions. How many seconds did it take to do it? 4, 5, whatever. You'll notice by looking at those gas meters that sometimes the dial hand gets a little catchy as it's rolling around. So if you can average that out, you can try to eliminate some of that factor.